Okay, we're going to work two more problems. I realized that I gave you odd problems on the first one, so I messed up your fun on two problems. So the two that I give this time, I'll give even problems, so I won't mess up your fun of working those problems on the homework. Okay, let's look at problem number 14. It says a crate is suspended by two ropes. One rope makes an angle, so we have the crate here. And we have one rope that makes an angle of 46 degrees and 20 minutes. In other words, we know 46 and 1/3, 20 degrees is a third of a minute. 46 degrees, 20 minutes with the horizontal, and has a tension of 89.6 pounds. And the other rope is horizontal, and find the weight of the crate and the tension on the horizontal rope. So we want to know the tension, and we want to know the weight. Now, we know that what happens is that this box is going to pull straight down. Weight goes perpendicular with the earth, so it goes straight down. So what we have then is the sum of these two is going to have to be opposite of that. So these two things have to match up. Weight going straight down, the weight going straight up. So and this is the sum of the two forces. I guess this force should be more like, should be a little shorter, shouldn't it? So we got this thing right here. And this is the sum of these two forces. In other words, I were to take this force, I move it up there, we know it'd be drawn like that, and that would be the sum. So basically what I need to do is find the y value of, or the y component of this force and the x component of this force. And when I do that, that's going to give me the tension here and the weight of the box. The y component is going to be the weight of the box. The x component is going to be the tension on the rope. All right, so to find that, we know that x is equal to r cosine of theta, and we know that y is equal to r sine of theta, just like we do on component vectors. So that would give me r is 89.6 cosine of, and theta is, and we're going to write it as 46 plus 1/3, like so. All right, and let's plug that into our calculator. Let me find my calculator again. And we would have 89.6 times cosine of 46 plus 1 divided by 3, close parentheses, and hit enter. I'm getting 61.86. That's my x component. So that would be the tension on the rope, 61.86 pounds. Next, I want to know the weight of the crate. That's the y component on this. There is no y force when it's going horizontal, no y force at all on it. So it's going to be just the y component of this. So that would be r, which is 89.6. And this time, since we're doing y, we know that that's sine of, and we got 46 plus 1/3 again. And so we plug that into our calculator, 89.6 sine of 46 plus 1/3, close parentheses, enter. And I see that the y component is 64.59 something. So the weight of the box is 64.59. Okay, I sure wish we were in class right now, and we'd certainly have a discussion. You guys work on this, and we'll see if we need a discussion from what you send to me. Okay, let's work another problem. And let's work let's go to 18. It says distance of a ship from its starting point. Starting at point X, a ship sails 18.5 degrees on a bearing of 189 degrees. So I'm going to go ahead and put my axis through here. This is my north-south axis. A bearing of 200 degrees. Remember, we're going to go clockwise. There's 180, and then another 20 degrees would get us to the 200 degrees. So I see that this angle right here is 20. Now, it would be nice to use bearings, but we can't. We're going to use our apps on this thing, not our programs. So when we get here, he's going to turn and he's going to go 2.4 kilometers, and it's going to be 320 degrees. So 320 degrees from 360 would give us 40 degrees. So it goes like this, and we've got a 40-degree angle here. Now, these are parallel lines, therefore alternate interior angles are equal. So if this is 20, we see that that is 20. Now, the question is, how far, I think it asks, let me read again. It says, find the distance of the ship from point X. So we're trying to find this distance right here. Now, this is 40, this is 20. We know this whole angle in here is 60 degrees. I did not label the magnitude of that one, which is 2.4. So I've got 2.4. Now, I've got this angle, which is 60. I've got this side, and I didn't write that in there either. Let me write it.